Okay, so solving inequalities, as I just mentioned, you already know how to do this. But there is one thing that's different about solving inequalities than when you're solving equalities. So, let me give you an example of one. Say I gave you, I don't know, 3x minus 1 is greater than, I don't know, 5. If you were going to solve this inequality, guess what? You do it the exact same way you normally would if that was an equal sign. Does anybody remember what the one thing is, though, that you have to keep in mind? Anybody remember, Liliana? Oh, you're so close, but it's not for subtraction. Anybody remember when you switch the sign?
When it's negative.
And what are you doing with that negative?
You're dividing?
Yeah, so it's anytime you multiply or divide both sides by a negative, you're going to flip the inequality symbol over. So let's put a big star in our notes because this is the most important thing you got to remember. Anytime you multiply or divide both sides by a negative, you must flip the inequality symbol over. And that's all because in negative land, everything's switched around. Right? Remember how we talked about how negative 3 is actually bigger than negative 5? Everything swaps. So, you just have to keep this in mind anytime you're dealing with inequalities. Otherwise, though, you solve it the exact same way you would a normal equation. So, what would I normally do? If that said 3x minus 1 equals 5, you would normally, I'm going to add 1 to both sides. Notice, I did not multiply or divide by a negative, so I don't do anything with the symbol right now. I just leave it the same, bring it down. And then I would divide by 3. Did I multiply or divide by a negative right there? No, so I still leave the symbol alone. There's my answer to this. Often you'll be asked to graph that answer. So just like you were on the other side, you could put a 2. What kind of a dot would go at 2? Open. And it says x is greater than 2, so I would shade to the
Right.
to the right. Yep. I never multiplied or divided by a negative number, so I never had to flip the symbol over. I'll do one now where you have to, because you don't always do it, right? Here's a perfect example. I never multiplied or divide by a negative, so I leave it alone. But here's an example. Let's say I had, I don't know, how about, I don't know, 5 minus x is greater than or equal to 1. So you're going to start off as if that was an equal sign. What would you normally do? You would minus 5 from both sides, right? Minus 5, because I'm trying to get the x all by itself. So that's gone. Did I multiply or divide by a negative in that step? No. So the symbol stays as it is. 1 minus 5 is negative 4. I can't leave it as negative x. I want positive x. So what would I do?
Into sign.
Yeah, I'm going to have to divide everybody by a negative 1. So right here, I'm dividing by a negative. So here is where I would flip that symbol over, and that is now a positive 4. If you multiply or divide by a negative, the symbol gets flipped over. If the number is positive, you leave it alone. So now I could graph this if I wanted. Open or closed dot at 4. Closed and shaded to the left. Let's try one more. Ready? Oh, wait. Did you write it down yet? I want to put it over here. Yeah. Try that one. Just like with an equation, you can take your answer and check it. Anything you shade over is an answer. So if you pick any number that you've shaded over and plug it back in, it's got to work. If it doesn't, something's wrong somewhere. Okay, did everybody get an answer? Did you guys distribute first? I knew you would, even though you don't have to, but it's okay. So if I distribute, that's negative 3x plus 18. Should I have flipped the symbol over? I just multiplied by a negative, so should I have? Did you guys flip the symbol right there? Or did you not? You didn't? Why not? Right. I didn't multiply both sides by a negative number. I just simplified one side. That does not cause a flip of the sign. It has to be both sides. Dividing both sides by a negative, multiplying both sides by a negative. I didn't do that. Right. So, right there, I didn't flip the sign. Now, maybe you minus the 18. 9 minus 18 is now a negative 9. And now I'm going to divide both sides by a negative 3. Here, yes, you would flip that symbol over. Hopefully you got there. Did you get there in the end? Did you graph this correctly? If you didn't graph it, go ahead and try right now. Open or close dot at 3. Open, and then you shade which way? To the left. Remember, when the variable's not first, I'm already irritated. So I'm going to rewrite this so that the variable is first. So I'm just going to mirror image it all over. The arrow's pointing at the x, the arrow's pointing at the x, and then the 3.
What if you just do the opposite way?
You can. You do what works for you. So, there you have it. Either of these two are the same thing. So if you're taking a test, right, and you put either one of those on the answer line, they're both right. So I don't care which one you put, and I don't need both. So if you just want to do it this way, that's fine. You do what you like. Just make sure that your graph comes out the same. So, does this make sense? You can even clear fractions with inequalities still. Same way. So, let's just do one with clearing fractions. Say you had, oh, I don't know. I'll just make it up. How about 4/9 minus 2/3 x is greater than or equal to, I don't know, 2. If you had something horrible looking like that, you absolutely can still clear fractions. It all works the same way. So what would you multiply everything by if you're going to get rid of those fractions. 9. Everybody agree? And now, if I do the math, remember, you divide down, multiply up. Divide down, multiply up. So my first number is 4. Minus, my next number is 6x. And then my last number is 18. I heard it somewhere. Should I have flipped the symbol over? No, I didn't multiply by a negative number. If I had multiplied by a negative 9, I am doing it to both sides, so I would have flipped it over. But 9's positive, so I'm just going to leave it. And now I just solve like I normally do. Minus the 4, minus the 4. I'm going to go over here because I'm running out of room. So it's negative 6x greater than or equal to 14. And then divide by negative 6, so what happens? You got to flip that sign over. 14 over 6 is really 7 over 3. How do you put that on a number line? Easy. I don't really care what the numbers are. It's helpful to have 0, but negative 7/3 is just somewhere over here. I don't care about the numbers around it. Closed out at negative 7/3, and then I would shade to the left.
Isn't it always what the sign arrows pointing to the side of the road?
As long as your variable comes first, yes. But if you did it like in this last one, where when you solved it, x is on that side, then it's the opposite, right? Unless you rewrite it so that the variable's first. Bless you. All right, what do you guys think? Good.